All right, so 5.5 part 2 goes over ambiguous cases of these triangles. Ambiguous cases just means that you have either two solutions, one solution, or no solutions for these triangles. So sometimes you'll be given different values for angles and side lengths that either do not give you a triangle, which you'll find out, or it gives you two solutions for a triangle. So if we look at some examples, for the first example that we're going to look at here, we're given a triangle ABC where angle A is 45 degrees, side length A is 7 square root 7, and side length B is just 7. So sometimes it's easier to draw ourselves a triangle and label our sides. It tells us that angle A is 45 degrees, so this one will be 45 degrees. The side length A is 7 square root 2, and side length B is just 7. And I know which side lengths are which because across from angle A is the side length A. Opposite of angle B, so across from it is the side length B. Opposite of angle C is the side length C. When it tells us to solve for the triangle, we're solving for all angles and all side lengths. So use your law of sines. For this, in order to, let's say we're going to find angle B first. We're going to use sine A over side length A is equal to sine B over side length B. For this, we're just going to plug in our values and solve for what we don't have. So this is going to give us sine 45 over 7 square root 2 is equal to sine angle B, which we don't have, over the side length B, which is 7. We can cross multiply with these. We're going to get 7 square root 2 sine B is equal to 7 sine 45. Now, with this, when you go to divide each side by the 7 square root 2 to isolate the sine B, you can simplify before you plug this into your calculator. If you do that, it's going to be a lot easier. So you're going to have sine B is equal to 7 sine 45 over 7 square root 2. They both have a 7, so you can cancel those out, and you're just doing sine 45 over the square root of 2. Now, I wait to put this in my calculator because I know that when I find this, or when I solve for this, I'm going to be solving for the angle B, which is going to be the inverse of sine, so that's sine to the positive to the negative 1 power of sine 45 divided by the square root of 2. So in our calculator, what I'm going to do first is that sine 45 divided by the square root of 2. When I get that, I get 1/2 or 0.5. So when I take the inverse of that, so I hit my second button, then my sine button again, and I put 0.5 in there, I get 30. So my angle B is 30 degrees. From here, we have angle B, which is 30 degrees. From here, we got to still find angle C. To find angle C, a whole triangle is 180 degrees. We would subtract the sum of the 2 degrees that we have, which is 45 and 30. 45 plus 30 is 75. So we're just doing 180 minus 75, which gives us that angle C is 105 degrees. So we're almost there. We have one part that's left in order to solve for, which is the side length C. We have angle A, we have side length A. We were given side length B. We had to find the angle B. So if it was me, I'd use what was given to me in what I'm going to set up next. So I'm going to use the sine of angle A over side length A with the sine of angle C over the side length C. So we're going to have sine A over A is equal to sine C over C. So this is just saying sine angle A is 45 sine 45 over 7 square root 2 is equal to the sine of angle C, which we said was 105 over C. And we find for C. Cross multiply. This is going to give us C sine 45 is equal to 7 square root 2 sine 105. We're going to divide each side by the sine 45. These cancel. We can use our calculator. I'm going to do 7 square root 2, move over, sine 105, close my parentheses and hit enter. From there, I'm going to divide that by the sine of 45 degrees. And I get 13.5. 2296157. I'm going to round to the tenths place, so that gives us a side length C of 13.5. So solving for a triangle means that you identify each angle and each side length. So angle A, they gave us 45 degrees. Angle B, we found was 30 degrees. Angle C, we found that was 105 degrees. From there, side length A was given to us, which is 7 square root 2. Side length B was given to us, which was 7. Side length C we found to be 13.5. If we look at the next example, we're going to be getting two solutions for this case. It tells us that triangle ABC has an angle A that's 43.1 degrees, a side length A that's 186.2, and a side length B that's 248.6. Now, if we draw our triangle, so we have a visual, we can label this A, B, and C. It tells us that angle A is 43.1 degrees. It also tells us that side length A is 186.2 and side length B is 248.6. All right, so we need to find for angle B to start with because we're given side length B. So to set this up, we're going to do sine A over A is equal to sine B over B. Now, sine A is going to be sine 43.1 over angle or side length A, which is 186.2. Sine B, we're finding for angle B. So it's just going to be over side length B, which is 248.6. We're going to cross multiply like we usually do, and we're going to have 186.2 sine B is equal to 248.6 sine 43.1. From here, divide each side by the 186.2. So you're going to have sine B is equal to whatever you get from this 248.6. Let's do this. 248.6 sine 43.1 divided by 186.2. This gives us 0.912254888. Who knows the rest? So with this, you have to find the inverse sine of this. When you find the inverse sine of this, you're just going to do the second sine, second answer, and it gives you that angle B is 65.818, so on. Now, typically, we would sit here and say, our angle B is about 65.8 degrees, and go with that. However, there's two possibilities here. It's either the 65.8 the 65.8 degrees, or 180 minus that. So if we did this, if we did this for, let's say this is angle B1, is going to be 65.8. For angle B2, because this will be our second triangle, we're going to have 180 minus 65.8. That's 114.2 degrees. So you now have two different triangles that you're going to be working with. You have one that we're going to label triangle A1, B1, C1. This is going to give us the side lengths of the 43.1 for angle A. B is going to be 65.8, and angle C is going to be 180 minus the 43.1 minus the 65.8, so that's 71.1. You're also going to have another triangle. We're going to label this one A2, B2, C2. We're going to have an A that's the same, so 43.1. Now, we said that B2 is going to be 114.2. So this angle B is going to be 114.2 degrees. So angle C is going to be 180 minus 114.2 minus 43.1 degrees, which is 22.7 degrees. So from here, think about what's already given to you. We have side length A, which is automatically 186.2, and side length B, which is 248.6. So we're going to do this for both of them. And then go from there. So the only thing that we have to find from here is the side length C for both of these triangles. If we work with the triangle A1, B1, C1 first to find side length C, again, I'm going to use what was given to me. I had my angle A, I had my side length A, so I'm going to use the sine of angle A over A is equal to the sine of angle C over C. We said that the side length A and the angle A would give us sine 43.1 over 186.2. For this angle C in triangle A1, B1, C1, we're going to have sine 71.1 over C. Cross multiply like you usually would. So we're going to have C sine 43.1 is equal to 186.2 sine 71.1. Divide each side by the sine of 43.1. And this gives us a C of 186.2 sine 71.1 divided by sine 43.1 is going to be 257.8. So that's for triangle A1, B1, C1. For triangle A2, B2, C2, we still have to find for the side length C. So we're going to do sine A over A is equal to sine C over C. So this is going to give us sine 43.1 over 186.2 is equal to sine 22.7 over C. From here, cross multiply, so we get C sine 43.1 is equal to 186.2 sine 22.7. From here, divide each side by the sine 43.1. These cancel. Use your calculator. 186.2 sine 22.7 divided by sine 43.1 gives us 105.9 100.2. So for both of these, you have two different scenarios here, so two different solutions to these triangles. For the triangle A, let's do it this way, let's do it in orange. Triangle A1, B1, C1, you have an angle measurement for angle A, that's 43.1 degrees. Angle B is 65.8 degrees. And angle C, we said, was 71.1 degrees. Now your side length A, we said was 186.2. B is 248.6. And we found C to be 257.8. Oops. So that's one situation or one option here with these two solutions. For triangle A2, B2, C2, we have an angle A, that's 43.1 degrees, and angle B, that is 114.2 degrees, and an angle C, that is 22.7 degrees. For side length A, again, that's a 186.2. Side length B, again, is 248.6. And we found side length C to be 105.2. So again, two different triangles for two different solutions for this example. For our next example, we're going to be dealing with a case that has no solutions. Now, you cannot take the sine of something and get something greater than 1. It's not possible. You don't have a triangle if that's the case. So, if you look at this example, we are told to solve a triangle, ABC, where angle A is 42 degrees, side length A is 70, and side length B is 122. So, if we draw ourselves a triangle, angle A, B, C, A is 42 degrees, side length A is 70, and side length B is 122, right? Yes. All right, so if we were to find the angle B, we're going to do sine A over A is equal to sine B over B. So this is going to give us sine 42 over 70 is equal to sine B, we don't know B, over 122. Cross multiply, so this gives us 70 sine B is equal to 122 sine 42. Divide each side by 70. Oops. We're going to get sine B is equal, we have 122 sine 42 divided by 70. So this is 1.166199057 and keeps going. In order to do this, in order to get the angle for B, you'd have to take the inverse of this. However, the sine of anything is never more than a positive 1. So, if you were just to say, to take the inverse sine of your answer, you would get an error in your calculator. So this is not possible to take angle B and find the inverse sine of that. So that is not possible, so this is not a triangle. Again, you cannot take the inverse of sine and it be a number that you're plugging in that's greater than 1. It does not work. You will always get an error in your calculator, always. For example 11, we are given a triangle, ABC. We're given that the measure of angle A is 70 degrees, the side length C is 26, and the side length A is 25. So again, if we draw ourselves a triangle, label it A, B, C, this is 70 degrees, this is 25, and then this side length is 26. So for this one, we'd have to find or use sine A over A is equal to sine C over C, since we're given side length C. You can't work with sine B if you're not given the side length for B. We plug in our values. We're going to have sine 70 over 25 is equal to sine C over 26. Cross multiply. So this is going to give us 25 sine C is equal to 26 sine 70. We're going to divide each side by the 25. These cancel. So you're going to have sine C is equal to 26 sine 70 over 25. To find what C is, take the inverse of that 26 sine 70 over 25. If we simplified first the 26 sine 70 divided by 25, we get 0.977. That's okay to do. So take the inverse of this. So angle C is going to be the inverse sine of 26 sine 70 over 25. If we type that all in our calculator, we get that angle C is about 77.8 degrees. Now, with this, I'm going to plug this in just so that way I know 77.8 is that angle. We still got to find for angle B. Now, you could also check to see if you have another side length that's possible, which it would be able to. You just do 180 minus the 77.8 degrees, and you would get 102.2. Now, if this was a possibility that there was two solutions for it, you'd be able to take the 102.2, add the 70 degrees to it that was given to you for angle A, and get something that's less than 180. If you're not, then you don't have that possibility of having the two different solutions. We're going to just work on this one that we have here just right now, not worrying about the second solution for this one. So continue with this. You're given the angle C. Now you have to find for angle B. In order to find for angle B, subtract the two angles that you have from 180. So angle B is going to be 180 minus the sum of angle A, which is 70 degrees, and the 77.8 degrees. So this is giving you that angle B, 180 minus 70 minus 77.8. It's 32.2 degrees. So I'm just going to put that in there too, 32.2 degrees. All right, so the only thing that we have to find now is side length B. So if we find for side length B, where I'm going to use sine A with side length A. So sine A over A is equal to sine B over B. So it's going to be sine, where was it, 70 over 25 is equal to sine 32.2 over B. So from here, we're just going to cross multiply. So we're going to have B sine 70 is equal to 25 sine 32.2. Divide each side by the sine 70. And we get the B, use your calculator, 25 sine 32.2 divided by sine 70 gives us 14.2 about. So look at all of the stuff that you have here. We found, or we were told that angle A is 70 degrees. Angle B we found to be 32.2 degrees. Angle C we found to be 77.8 degrees. Side length A, they gave us 25. B we found to be 14.2. And C, they gave us 26. You guys got to remember, if it's asking you to solve for these triangles, it means you need all 6 parts of it, all 3 degrees or angle measurements and all 3 side lengths. For our last example, we're given that the angle for B is 45 degrees, side length A is 28, and side length B is 27. So I'm going to just draw ourselves a triangle, label it A, B, C. We're told angle B is 45 degrees. Side length A is 28 and side length B is 27. So to find angle A, we're going to do the sine 45 over 27 is equal to the sine A over 28. Multiply by cross multiplying, you're going to get 27 sine A is equal to 28 sine 45. Divide each side by the 27. These cancel. Use your calculator. So 28 sine 45 divided by 27 gives us 0.733, so on. We're okay to work with that. So keep going. From here, we would take the inverse of that. Oops. Angle A is going to equal this inverse of 28 sine 45 over 27. This gives us 47.2 degrees. Again, to find the other option, you would take 180, subtract the 47.2 from that. You get 132.8. If you add that with the 45, it's still less than 180, so you'd have 2 solutions for this one as well. Again, we're just going to work with one of them for right now and work the rest of the way through this. So we found angle A, which is the 47.2. We got to find angle C. Angle C is that 180 minus the sum of 45 and 47.2. Which gives us 87.8. And then we just have to find for the side length C now. So we're going to do what they gave us. Sine 45 over 27 is equal to the sine of angle C, which we said was 87.8 over C. Cross multiply. So we have C sine 45 is equal to 27 sine 87.8. Divide each side by the sine 45. And we get that C is equal to 27 sine 87.8 divided by the sine of 45 gives us 38.2. Yes. So for our solution for this one, we're going to have the angle A to be 47.2 degrees. Angle B is 45 degrees. Angle C is 87.8 degrees. Side length A is 28. Side length B is 38.2. No, sorry. Side length B is 27. And side length C is 38.2.